Guys, so I've onslaughted you with one chromatography system after another. HPLC, GC, IC, Headspace GC, Purge and Trap GC. It just seems like it just keeps coming and coming and coming. And then we talked about spectroscopy. So ion coupled plasma spectroscopy, atomic absorption spectroscopy, atomic emission spectroscopy. So it seems like there's an assortment of different maybe instrumentation out there or technology for me to choose from. And it looks like we've got quite a bit of every single thing that could be out there in a way, right? Well, there's another instrument that we need to talk about, and this is called a UV-Vis. So because we ended in the spectroscopy field, not really, because we kind of squeezed ion chromatography in there in the middle, right? But we talked about AA and AE and ICP, so it's going to be a natural fit to kind of pick up from the spectroscopy world and talk about ultraviolet visible spectroscopy. So the UV does stand for ultraviolet, and the Vis stands for visible. Okay, so let me kind of give you a breakdown about what's happening here. Imagine this is the electromagnetic spectrum. So electromagnetic spectrum. In the electromagnetic spectrum, this represents all waves of energy, all right? And we sometimes would associate it with this as light. So our eyeballs are detectors. We can see colors. We can see things, right? That looks a little bit different. Well, that's the visible region. That is what we call Vis. All right, well, the visible region just makes up a very small sliver of that electromagnetic spectrum. Just a little bit of it, and that is it. All right, and in the visible portion, this is where I would find Roy G. Biv. Roy G. Biv stands for red, orange, yellow, green, blue, indigo, violet. Those are the colors that I see. Those are the colors my eyeballs see. So my eyeballs, again, are detectors, and I'm the walking instrument for that. Well, we have an instrument in the laboratory that can see color, and that is the UV-Vis instrument, because I see the word Vis in the name, okay? Well, here is violet. There's violet. So violet, if I continue on and go above violet, I get into the UV region, all right? And that's kind of what symbolizes ultra. So red, orange, yellow, green, blue, indigo, violet, ultraviolet, superviolet coming to the rescue. All right, well, it doesn't really come to the rescue, folks, because the UV portion, the UV is nasty. Go lay in a tanning bed. You're sitting under UV lamps. Those UV lamps are burning your skin to a crisp. And then when you get in your 30s and 40s and 50s, and you look like a little leather bag walking around, then you can say, well, Tracy tried to warn me not to lay in those tanning beds because this is what's going to happen, and now I look like a saggy old leather bag. So don't lay in the tanning beds. That's UV light. And UV light is powerful. If it can give you a sunburn within a matter of minutes, just imagine if you were exposed to it for a long period of time. Okay, so UV-Vis works on that electromagnetic spectrum. It sees the ultraviolet piece and it sees the visible piece. Okay, so why would I use this instrument? Well, if I had a colored solution, maybe it's purple, maybe it's yellow, maybe it's red, my eyes can distinguish very easily from one color to the next. But what if different hues are available, right? So what if it's kind of red, but then it's kind of salmon, and then it's kind of pink, and then there's a little bit of in between of each one of those colors? Would I be able to really tell the Crayola box of colors which color is which? And the answer is probably not, right? Unless my eyes are really, really trained, probably not. Okay, so these colored solutions, they can be presented to me with different concentrations of color. Some might seem a little bit darker than others, right? And my eyes are going to have a really hard time determining that. Well, that's the purpose of a UV-Vis. The Vis portion of this instrument can go into a colored solution, and it can kind of tell me how the color is absorbing light. And then I can relate that to concentration. How strong is the sample? It's really what this is all about. Okay, what is present in the sample and how much of it's there. We've seen that in all of the equipment so far, pretty much all the way down the board, right? Well, it also dabbles in the UV. So what kind of things will we do in UV? Well, these are typically organic compounds. Organic compounds, again, are carbon-based compounds. They have a carbon backbone, so they are majority made up of carbon and hydrogen. And they can have some oxygen or sulfur or nitrogen or bromine or iodine kind of thrown into the mix to mix it up a little bit. But for the most part, it's heavily organic, heavily carbon and hydrogen based. Okay? So the UV portion would do an excellent job for organic compounds. So for instance, aspirin. Aspirin's a pill I take for a headache. Maybe. It's one option. You could also take Tylenol, which is acetaminophen. That's still an organic compound, though. You drink your coffee in the morning. Your coffee probably has caffeine in it. Well, that caffeine is an organic molecule. And all three of those would be wonderful candidates for a UV-Vis instrument, because they are organic compounds, and organic compounds can be detected in the UV range. So now I guess you're kind of scratching your head and you're saying, well, wait a minute. I thought that HPLC does a really good job in measuring organic compounds. So why do I need a UV-Vis to measure the organic compounds? Well, here's the thing. The HPLC system is the separator. It separates things into the batches. That was the purpose of the column, right? It went through, it took a complicated sample, it separated the pieces into their own little piles or stacks, and then it sent them out one by one out of the instrument. UV cannot do that. UV cannot separate things. So the purpose of a UV really is to measure pure compounds, pretty much give or take a little bit. That means it's typically got to be very clean. It cannot be complicated. It should only have maybe one or two components in it at the most. And if so, then this is a compound that I could use for my purpose in the laboratory to run on a UV-Vis instrument. Well, remember I kept saying HPLC, after it separates, it then goes into a detector. The detector was the eyeball of the instrument. That detector could be a UV-Vis instrument. They could be coupled together. That's how these things work. So HPLC does the separation, and it kicks the components out one by one, but the UV-Vis is the detector. It's another piece that's hooked up to that HPLC instrument, and it begins to look for things as it comes its way. That's the beauty of chromatography and spectroscopy. They work hand in hand. All right, so this is why I would use a UV-Vis instrument. Okay, I would have a colored solution. I need a concentration. I would have an organic solution that's pretty pure or pretty clean, and I would want the concentration of it as well. So for instance, let's say I go to the grocery store and I buy an aspirin tablet. That aspirin tablet says 325 milligrams. I crush this tablet down. There shouldn't be a lot of other stuff in there. It should just mainly be aspirin, right? So because of that, I don't need to really separate anything. Aspirin's just going to be crushed down into the tablet, into a powder. Then I can dissolve that powder up into a solution, and I can run that solution on a UV-Vis instrument. And I can get the concentration of the aspirin. So I can come back and say, is it really 325 milligram? The UV-Vis will kind of help me determine that. At the same time, though, the UV-Vis is commonly used as detectors for other instruments. So I can have a standalone version that I can work with, or I can have a coupled version that is in line with a chromatography system like HPLC, and it will do the same job. It just constantly gets fed by the HPLC instead of me directly. All right, now, these UV-Vises. The UV-Vis instruments costed us around $8,500, give or take a little bit of money during that time. We had to buy software to make the thing work. We had to buy the computer to make the thing work. And we also have to have cuvettes. Cuvettes are basically tools, sample holders in a laboratory that will hold my colored solution or my organic solution in. So that way I can put these cuvettes into the instrument and analyze and run them. The cuvettes, though, those cuvettes, they can range in price. They can be pennies a piece if they're just normal plastic. Sometimes that doesn't work, though. So sometimes we have to order quartz cuvettes, and those could be upwards of $125 to $200 a piece, depending on the manufacturer and who makes them. So they can be expensive, and if you break them, then we can start eating the cost of the quartz cuvettes, because that's tons of money that we have now wasted that we're going to have to replace with another quartz later on in the future. Okay? So this is a story with UV. Now, who makes our UV-Vis instruments? Okay, so this is a company called Thermo. So I'm going to bring them up. Here's Teledyne Tecmar's website. And the name of our UV-Vis instrument is called the Thermo Genesis 10S. All right, so here it is. It's from Thermo Fisher. Thermo Fisher is a chemical supplier company. It's part of the Fisher brand product, I guess. And Fisher Scientific is a place that we would order general chemicals and reagents with. So for instance, if we needed acids or bases or just simple salts or salt, NaCl for a laboratory, this is one manufacturer or supplier that we can order from to get those samples with. But they also have a line called Thermo Fisher Scientific, and that is really kind of geared toward more instrumentation and technology aspect of what they offer. So this is the exact UV-Vis that we have in our instrumentation room, and we have a total of 3 of these, and they work out quite well. So they are standalone units. However, they can also be hooked up to a computer and software and can be software controlled. And that's how we've got ours set up. We have it hooked up to a printer, hooked up to a computer, hooked up to some software, and everything that we want the instrument to do, we make those setting changes in our computer and relay it to the instrument that way. Okay, so $8,500 is typically what we paid for these instruments back when we ordered them. They could be more expensive or cheaper nowadays. Who knows? I don't really know. But it's a small footprint, easy to transport and storage, operates without computer control if you want it that way, or from a computer that uses what we call the Vision Light software. You can do a little bit of everything with it, quantitative work, just measure a sample, make it have calibration curves, whatever the case is. Pretty cheap, pretty reasonable, pretty easy to use. No big warnings here at all. It doesn't take a lot of money to keep it operational either. This thing has what we would call a xenon arc lamp, and that xenon arc lamp will typically be good for about, I would say, 10 years, if not longer. So we don't even have to worry about replacing the bulbs with new ones every year or every 6 months like we used to have to with some of our older models. So, of course, these things can be more expensive, but there is our Genesis 10S UV-Vis spec. So good luck on the assessment with the UV-Vis portion. Again, very simple. We're just covering the top layer, and we'll wait until the instrumentation classes to really talk details.